All right, this is for dynamics, check-in number 9. Um, Overall, I spent quite a bit of time in the last week on chapter 15, the rigid body kinematics. Overall, just spent. I went through pretty much all the videos on the channel, a few other videos on YouTube, just solving problems. And then the rest of the time I spent pretty much just solving the problems, the homework, and then the additional problems that aren't in the homework that have the solutions. Yeah, I'd say overall I spent probably 20 hours or more just going through everything, making sure I understand for the exam, which I'm taking tomorrow. So yeah, I mean, I learned quite a bit as far as the, acceleration, velocity, position, even based on, the object itself, because usually we would just do it based on a particle, like as a single, we would just put the whole body as one mass, one particle, and then you can do the kinematics from there. So it was definitely a little bit of a change where the actual, shape of the object and how it's connected. Ultimately, you have to use different equations and kind of piece things together differently. So, yeah, for instance, I mean, the equations are different. We're now dealing with a lot of vectors. As you can see for the acceleration, we have the angular acceleration crossed with, the distance. So this will be like your tangential acceleration, and then this will be your normal acceleration pointing in, because this has to do with the angular velocity. Stuff like that. Yeah, pretty much really just using this equation quite a bit. The velocity at point B is the velocity of point A plus the angular velocity times or crossed with the distance from B to A. So yeah, lots of those questions. Really just solving them was slightly different as well, as far as like you would solve for the velocity in vector form, and then you'd actually just separate it into I and j or k components, and then you can solve for things that way. If part of it is only moving in one direction, like it's locked in place and it's only moving in the x direction, then you can do the cross product here, find the original velocity in ijk format, and then you can actually just split it into components, and if it's only moving in the x direction, the y components are going to equal 0. That allows you to solve for the angular velocity of the second part that's moving of B to A, and then you can plug that back into the y direction to solve for the actual velocity itself at that point. So yeah, it was just a little bit different, kind of like a mixture of statics and kinematics, obviously. Yeah, here's just some of the problems I solved, more of the notes. And then here's the homework assignment. As you can see, it's pretty thick. I think it was about 15 pages. So yeah, I mean, most of the time just went to going through the homework and trying to figure this out. But yeah, we did it. It makes quite a bit of sense. I feel prepared for the exam. So yeah, guess I'll end the video there. Thanks.